Hello everyone, today we're going to record a linear regression, so I'll call it linear regression. Then inside here I'll create the Python file linreg py.py. So let's dive into it. So what is the linear regression actually is? We'll go into the home and we'll type formula of linear regression. So as you can see, this is y is equal to m multiplied by x plus b, and this is basically it. So yeah, in other words, this. So it's more fancy, but anyways, let's actually implement it. For the implementation, I'll use the library which is called numpy. They I'll cast it as np, which is common. So first things first, I'll create the variable x and I'll assign into this variable np.array, and then inside this array there's going to be range, but yeah, I believe no. First of all, I'll create random and then uniform method. So uniform, what it does is that it takes range of the numbers, which is, I mean, for the sake of simplicity, -10, and then high is going to be 30, and then our actual size gonna be, let's make it num samples. So this num samples I will put into here, and we'll say it's going to be 50. So what I've made right now, I've made range from -10 to 30, and numbers inside my array will be randomly distributed between this range. So let's check this actually out in our console. Yeah, and we didn't get anything because I didn't print it. So again, let's print first 10 elements, so to know what is it actually. So as you can see, 2, 2, 9, and then 2. This is not quite big range. Oh yeah, here. So 20, 21, 16, then -4. Yeah, this is actually it. So the next things, what I'm about to do is create the function which is implement the linear regression. Linreg and then parentheses, then colon, and first, yeah, I'm going to receive some array x, and then say that y is going to be equal x, well, we can use as in formula says m, but what I'm about to do is I want to use b. So as here b, which is slope, so let's use, oh no, this was a mistake. So yeah, this is actually slope, and it's kind of b. I'm not sure with notation about it, but instead of m, let's use w, which is common approach for the data science. So and then plus we're going to use b, which is also common approach in the data science, because w represent weight and b represents the y-intercept, right? So if we'll check it here, so b is the estimated intercept. So yeah, and for us we will call it bias just for now. So and then we will pass the same elements inside our function. So actually we can already return our y values. Now let's actually do it for the sake of simplicity at first time, but then we will a little bit improve our version of code. So we return y, and now we are about to create our y. So y are going to be a len reg, and then inside the parentheses I pass my variable x, which is our x values. Then random w, which is weights. So let's make it 0.6 for now. and our bias is going to be 1.2. So now to see what we actually did is we're about to use our library, which is matplotlib.pyplot and then as plt. So plt that title is going to be generated data, and then plt that scatter are going to receive x is uppercase X, which is our x values, and our y, which is y values. So this is actually it. We actually can also define the color, which is going to be quite simple, blue. So and then plt.show, so to show what we've done. Hope it will work fine. Let's check this out. And yeah, we've got our linear regression model. So we have range from 15 by y. From -5 till probably 20 in y-axis, and from -10 till 30 in our x-axis. So this is actually what is linear regression is, but I want to dive a little bit deeper. So we actually didn't get something like that, but this is what we are about to make right now. So to make this, we are about to change our y values, because again, if I'll run this, you see the y values, they go straight to the point where they should be. But what I'm about to do is make a little bit noise between them, that the y values may be a little bit interrupted in one of the sides, or not interrupted, a little bit thrown out of this visual line, almost line. So yeah, you'll get it. You'll get into this now. So what I'm about to do is to say that y is going to be equal y plus. So what is going to be here is np dot random and then randn, which is standard deviation. So and the standard deviation, I wanna say that my size of the standard deviation, or how many samples will be inside, will be equal to num samples, which is 50. So we will add this random deviation, standard deviation, 50 again. So we have y, which consists inside itself 50 values, and we're about to plus or some random values which are going to be random distributed. So which you will see actually right now. So if I'll run it again, as you can see, it's quite more it's quite similar to what we saw here, as you can see. So probably for the sake of not simplicity but visualization, I'm going to run it again with 150 samples. Yeah, it's distributed kind of in the same range, but anyways, so this is basically what I was about to get, and this is basically our linear regression. And the problem of the linear regression is how to find the best slope, which best will and best way will represent what this value actually are, like this line. So if we will get into this image, as you can see, this line bestly represents the distribution of the samples. So it says that most of the samples goes in such intercept, in such slope, and they are concentrated in some of the line points, kind of this way. So yeah, this is actually what we did. So in the next lesson, we are about to implement this line, and this line can be implemented by the neural network, which is data science field itself. So let's dive into it in the next lesson.